Standalone internal functions. In both C and Phi, pretty much everything that does anything of any use in your program happens inside functions. The Pascal and Fortran programming languages have something called a procedure or a subroutine, but these are basically functions that don't have any arguments and don't return any values. They aren't needed in C or Phi because you can create functions with no arguments and no return values if that's what you want. So functions are all we need. A function is basically a routine that you can call as many times as you want in your program instead of having to write redundant code over and over again. This makes your code more compact and easier to understand. When a function is called, a series of values called arguments can be passed to the function by the caller. These values influence what happens in the function. For internal calls at least, while the function is running, the caller is suspended until the function completes. A value is then optionally returned by the function back to the caller. This value can be stored, tested, or even just ignored by the caller. The particulars of how a function works in C and in Phi are pretty much the same. There really is very little difference between the two languages in this area besides their syntax. But there are some minor differences. Before you call a function, its interface must be declared in what is called a prototype in C. We can still call them prototypes even when we are programming in Phi. For that matter, we could also call extern declarations in C prototypes as well. They serve an analogous purpose. What makes a function prototype different from a function definition is that the function body is missing in a prototype. The prototype exists to tell the compiler how a function is to be called. So comparing a function definition written in C on top with one written in Phi on the bottom, we can see the similarities are striking. The return types are the same, but their names are different in the two languages. The return type must be followed with a colon in Phi as opposed to one or more spaces in C. The arguments are separated by commas in both examples, but here again the syntax for individual arguments is different for the two languages. Finally, we see that the braces used to enclose the function bodies look different, but are functionally the same. In both examples, the function prototypes don't have their bodies and are terminated with semicolons. In C, if there is no return type specified, the return type of int is assumed. But if the function returns no value, then you must place the keyword void where the return type would otherwise appear. This doesn't make a lot of sense, and it is one of C's quirks. The reason for this is because the implied return value of int was part of C from its very beginning. The concept of no return value was added to the language later on. So much code had been written by then that no one wanted to change that part of C. When you write a function in Phi that returns no value, then put the void character in the place where the type would have gone had the function returned a value. Then follow it with a colon. Recall that a function name in Phi can be constructed from a set of characters that is larger than the 63 allowable in C. For example, the function name might just be the Greek letter delta instead of the English word delta. Your choice. The argument list is a series of declarations separated by commas in both languages. If no arguments are permitted in the function call in C, then you must place the keyword void between the parentheses where the arguments would otherwise appear. In Phi, just the absence of any arguments means the same thing. Once your function is executing, the arguments that were passed by the caller look just like locals that were already present before the function started to run. Since the caller set up the arguments before the function was called, the caller is also responsible for tearing them down after the function is finished executing. There is another important difference between functions in C and in Phi. In C, functions are public by default, while they are private by default in Phi. Public means that they are visible and accessible from other modules that are compiled separately. Private means they are not visible nor accessible from other modules that were compiled separately. In C, you can override the default of public in functions by preceding this declaration with the keyword static. To make the compiler aware of a public function outside the current compilation unit requires nothing more than the prototype. The keyword extern that is necessary for datums is implied for functions. In Phi, the default scope is private for both functions and datums. To make either into a public, their names must be annotated with the double dagger where they are defined. If the item is defined outside the current compilation unit, then it must be annotated with a single dagger. So the prototype declares that part of a definition that tells the compiler how to call a function. The body of the function definition defines what is done inside the function. This is where the really interesting action takes place. Think of the left curly brace in C or the left program brace in Phi as the open local scope, and the right curly brace in C or the right program brace in Phi as the closed local scope. Inside these delimiters, program statements are executed in the order they appear unless a special program control mechanism causes execution to go somewhere else. Once inside these braces, you can declare local items such as variables that only exist while your program is executing inside the function. This is also where you can write executable statements such as assignments. When your function is finished with its work, you must return values using the return keyword followed by the value you want to return to the function's caller. If the function has no return value, then the return keyword will not be followed by an expression. The return statement is always terminated with a semicolon. As in C, you can call a function and store the return value to a variable or use the return value in an expression. You can also ignore the return value by just calling the function and not doing anything with the return value. It is just thrown away. One of the most powerful features that C inherited from C++ is the additional nesting of scopes by using nested curly braces or program braces in C or Phi respectively. These can either be the ones that are part of existing control structures or they can be added by themselves. For example, suppose you want to swap the values of two variables in your C program and you don't care to make the temporary variable accessible to the whole body of the function. You can just add two curly braces where you want them to be used. Inside the curly braces, you can define a local variable and write the code that swaps the values. When the program exits the local scope, the temporary variable goes away and it no longer occupies space on your program's stack. This feature is so cool that Phi has it too, except that your program braces look a little different. Of course, in Phi you don't need a temporary variable to do a swap, but there are lots of other reasons you will come across to make use of nested local scopes. Local scopes, where you can create local resources for temporary use, are created almost everywhere program braces are used. We will see later that there is one caveat when we talk about the repeat while and repeat until control structures. You can declare a datum anywhere within a local scope. It is created the instant that the scope becomes active, even though there may be many executable statements preceding it. But if it is initialized, the assignment in its definition doesn't actually happen until program execution reaches the place in your program where the declaration is. The assignments that initialize local datums execute just like they would if they were regular assignment statements. Besides standalone internal functions, Phi also supports functions that are associated with objects. This is one of the object-oriented advancements in C++. Also, in Phi you can make calls to software that is outside your running program using external function calls. There is no equivalent to this feature in C or C++. These are advanced topics that we will talk about in future tutorials.